exercise 8.3 from the chapter Introduction to Trigonometry. So in the first question, they're asking us to express the trigonometric ratios sine A, secant A, and tan A in the terms of cot A. So first of all, let's start with tan A. Because we know that tan A is the reciprocal of cot A, and it can be written as 1 by cot A. Secondly, we know the identity that 1 plus cot square A is equal to cosecant square A. And we know that sine A is the reciprocal of cosecant A. So if we can write cosecant A in the terms of cot, then the reciprocal of it will be sine in the terms of cot A. So since we have a square on this side, we're going to bring it over to the left hand side, so it'll become the square root. So we will get whole root of 1 plus cot square A, which is equal to cosecant A. And we know that sine A is equal to 1 by cosecant A. So that means we know the value of cosecant A, which is equal to whole root of 1 plus cot square A. So we can substitute that over here. So we will get sine A is equal to 1 by whole root of 1 plus cot square A. Next, they're asking us to represent secant A in terms of cot. So we know the identity 1 plus tan square A is equal to secant square A. And using this identity, we can also notice that tan is the reciprocal of cot. So if we can write secant in the terms of tan, then we can find its reciprocal, which will be in the terms of cot. So first we need to isolate the secant A separately. So we'll bring the root over to the left hand side. So we will get whole root of 1 plus tan square A, which is equal to secant A. And tan square A can be rewritten as 1 plus 1 by cot square A. And since we have cot square A separately on the denominator and we have 1 here, we're going to cross multiply so that they both have the common denominator. So we will get cot square A plus 1 by cot square A, commonly on the bottom, which is equal to secant A. And we know that if the whole root is for both the numerator and the denominator, we can write it separately as root of cot square A plus 1, and separately here on the denominator as root cot square A. So we know that root cot square A is the square and the root will get cancelled, so we will be left with cot square A plus 1, root of cot square A plus 1 by cot A, which is equal to secant A. So this is secant A in the terms of cot. So in the second question, they're asking us to write all the other trigonometric ratios of angle A in terms of secant A. So we need to find sine A, cos A, tan A, cosecant A, and cotangent A in the terms of secant A. So first of all, let us start with cos A, because we know that cos A is the reciprocal of secant A. Next, let's start with tan A. Using the identity 1 plus tan square A is equal to secant square A, we can isolate the value of tan A in order to express it in the terms of secant A. So we can write tan square A is equal to secant square A minus 1. And since we have the square here, when brought over to the right hand side, it'll become tan A is equal to the whole root of secant square A minus 1. So next, let's do cot A, because we know that cot A is equal to 1 by tan A. And since we've already expressed tan A in the terms of secant A, we can substitute the value of tan in the terms of secant on the denominator, and we will arrive at the answer, which would be cot A expressed in the terms of secant. So since we found out here that tan A is equal to secant square root of secant square A minus 1, we can write cot A is equal to 1 by root of secant square A minus 1. Next, let's do cosecant A. So using the identity that 1 plus cot square A is equal to cosecant square A, we can write, we first have to isolate cosecant A and bring the root square over to the left hand side. So we will get root of 1 plus cot square A is equal to cosecant A. And we have already expressed cot A in the terms of secant here. So we can simply substitute the value of cot in the terms of secant in this equation. So then we will arrive at the answer where cosecant A is expressed in the terms of secant A. So we can write the whole root of 1 plus, where we've expressed cot A in the terms of 1 by secant square A minus 1. So we need to express cot square A. So we just need to square on both sides when we're substituting it here. So we will get 1 squared is 1, and the root and the square will get cancelled, so we will get secant square A minus 1, which is equal to cosecant A. Next, in order to ensure that they both have the same denominator, we're going to bring over this secant square A minus 1 over to the numerator by cross multiplication. So we will get whole root of secant square A minus 1 plus 1 whole divided by secant square A minus 1. And secant square A minus 1 plus 1 will get cancelled. So we will be left with root of secant square A by whole root of secant square A minus 1, which is equal to cosecant A. And here the root and the square will get cancelled, so we will be left with secant A by root of secant square A minus 1, which is equal to cosecant A. Next, let's represent sine A in the terms of secant A. We know that sine A is a reciprocal of cosecant A. So we can write sine A is equal to cosecant A, 1 by cosecant A. And previously, we have expressed cosecant A in the terms of secant here. So we've written cosecant A is equal to secant A by root of secant square A minus 1. So we're going to substitute that value here in order to find sine A. So when we substitute the value of cosecant A in the terms of secant, then we can write secant A by whole root of secant square A minus 1. Because cosecant A is also equal to secant A by root of secant square A minus 1. So now, in order to simplify this, we will bring root of secant square A minus 1 to the numerator, because there are two fractions in division, so it'll just become if it's two fractions in division, then we have to multiply its reciprocal. So we will bring root of secant square A minus 1 to the numerator, and on the bottom we will have secant A. In the third question, they're asking us to choose the correct option and justify our choice. So in the first question, they've given 9 secant square A minus 9 tan square A, and we need to prove whether it's equal to 1, 9, 8, or 0. So first we will notice that the term 9 is common for both of the terms. So that implies that we can take 9 commonly outside. So on the inside, we will be left with secant square A minus tan square A. And we know the identity that 1 plus tan square A is equal to secant square A. So if we bring 10 over to the right hand side, we will get 1 is equal to secant square a minus tan square a. And this is exactly what we have here. And we know that the value of secant square a minus tan square a is equal to 1. So instead of secant square a minus tan square a, we're going to substitute the value of 1. So 9 times 1 is equal to 9. And in the given options, the option B, the value is 9. So the answer is option B. In the second question, they've given 1 plus tan theta plus secant theta times 1 plus cot theta minus cosecant theta. So first, we're going to express tan, secant, cot, and cosecant in the terms of cos and sine. So it'll be easier for us to simplify it. So first part of the equation, tan theta can be represented as sine theta over cos theta plus secant theta. We know that secant theta is a reciprocal of cos theta, so we can write secant theta is equal to 1 by cos theta times 1 plus cot theta can be represented as cos theta minus sine theta minus cosecant theta, which is the reciprocal of sine theta, so cos theta by sine theta minus 1 by sine theta. So first, in order to multiply both of these terms, we're going to ensure that they both have the same denominator. We will notice that 1 in both cases do not have the same denominator, cos theta and sine theta. So we're going to multiply it by cos theta on both the numerator and the denominator. So we will get cos theta plus sine theta plus 1 by cos theta times 1 sine theta plus cos theta minus 1 by sine theta. So another interesting thing that we will notice here is that we have cos theta plus sine theta plus 1 and sine theta plus cos theta minus 1. So if we assume that cos theta plus sine theta as one single term, that means this is in the form a plus b times a minus b. And we know that a plus b times a minus b is equal to a squared minus b squared. And this only occurs when we notice that we can take cos theta and sine theta as one single term plus 1 and sine theta plus cos theta as one single term minus 1. So it is a, this we're going to assume as a, this would be b, this would be a in our case, and this would be b. So now we can express this as a squared minus b squared. So this would essentially be cos theta plus sine theta, the whole squared, minus 1 squared, whole divided by cos theta times sine theta. And this is in the form of a plus b the whole squared, which can be written as a squared plus 2ab, which is 2 cos theta sine theta plus sine squared minus 1 whole divided by cos theta times sine theta. And cos squared plus sine squared is equal to 1 because using the identity cos squared theta plus sine squared theta is equal to 1. So cos squared theta plus sine squared theta is equal to 1, and 1 minus 1 will become 0. So those two terms will easily cancel out. So we will be left with 2 cos theta sine theta divided by cos theta sine theta. And cos theta sine theta on both the numerator and the denominator will get cancelled, so we will be left with 2. And in the given options, the option C is 2. So the answer is option C. In the third question, we have been given secant A plus tan A times 1 minus sine A. And we need to prove whether it's equal to secant A, sine A, cosecant A, or cos A. So let us represent secant A and tan A in the terms of cos and sine. So we know that secant A is the reciprocal of cos A. So secant A can be represented as 1 by cos A. And tan A is basically sine A by cos A. This times 1 minus sine A. So, since both of them already have the same denominator, we can simply add the terms. So 1 plus sine A whole divided by cos A times 1 minus sine A. And we will notice, like in the previous question, this is in the form a plus b, a minus b. So this can be written as a squared minus b squared. So 1 squared minus sine squared by cos A. And we know that from the identity, sine square A plus cos square A is equal to 1, where cos square A is equal to 1 minus sine square A. So that means 1 minus sine square A is equal to cos square A over cos. And since cos square A is the same thing as cos A times cos A, we can cancel the squared. So we will be left with cos A. And in the given options, option D is equal to cos A. So the answer is option D. In the fourth question, they've given 1 plus tan square A by 1 plus cot square A. So we know that tan square A and cot square A can be represented in the terms of sine and cos. So we can write 1 plus tan square A is equal to sine square A by cos square A, whole divided by 1 plus cos square A by sine square A. In order to ensure that they both have the common denominator, we can write this as cos square A plus sine square A by cos square A, whole divided by sine square A plus cos square A by sine square A. So we're going to bring sine square A over to the numerator and sine square A plus cos square A over to the denominator. So we will get cos square A plus sine square A times sine square A, whole divided by sine square A plus cos square A times cos square A. And we know that cos square A plus sine square A is equal to 1, and sine square A plus cos square A is also equal to 1. So it will be basically 1 times sine square A, which is equal to sine square A, whole divided by cos square A. And we know that sine square A divided by cos square A is equal to tan square A. So from the given options, the option D is equal to tan square A, so the answer is D. In the fourth subdivision, the first question, they're asking us to prove the following identities, where the angles involved are acute angles for which the expressions are defined. So in the first question, they're asking us to prove cosecant theta minus cot theta, the whole squared, is equal to 1 minus cos theta divided by 1 plus cos theta. So first, let us express cos theta and cot theta in the terms of sine and cos. So we know that cos theta is the reciprocal of sine theta. So cos theta can be represented as 1 by sine theta, minus cot theta can be represented as cos theta by sine theta. And since they both have the common denominator, we can simply add both of the terms. So we will get 1 minus cos theta by sine theta. And let us not forget the squared, which is in the question. So since the square is for both the terms in the fraction, that means we have 1 minus cos theta, the whole squared, divided by sine squared theta. And we know that 1 minus cos theta, the whole squared, can be written as 1 minus cos theta times 1 minus cos theta. And sine squared theta, as we know from the identity, that cos squared theta plus sine squared theta is equal to 1. Sine squared theta can be written as 1 minus cos squared theta. And this is in the form a squared minus b squared. So that means it can be written as a minus b times a plus b. So we will get 1 minus cos theta times 1 minus cos theta, whole divided by 1 minus cos theta times 1 plus cos theta. And 1 minus cos theta will get cancelled. We will be left with 1 minus cos theta by 1 plus cos theta. And this is what they're asking us to prove, so we can write hence proved. In the second question, they're asking us to prove cos A by 1 plus sine A plus 1 plus sine A times by 1 cos A is equal to 2 secant A. So we can solve this by cross multiplying. So when we cross multiply, we will get cos square A plus 1 plus sine A times 1 plus sine A whole divided by cos A times 1 plus sine A. So 1 plus sine A times 1 plus sine A is equal to 1 plus sine A the whole squared, which can be written as 1 squared plus sine squared A plus 2 sine A whole divided by cos A times 1 plus sine A. So we will notice that we have cos square A plus sine square A. We know that cos square A plus sine square A is equal to 1. So 1 plus 1 squared is equal to 1 plus 2 sine A whole divided by cos A times 1 plus sine A. So 1 plus 1 is equal to 2, so we will get 2 plus 2 sine A. 2 we can take outside as common, so we will be left with 2 times 1 plus sine A whole divided by cos A times 1 plus sine A. 1 plus sine A and 1 plus sine A will get cancelled. We will be left with 2 times 1 by cos A. And we know that secant A is the reciprocal of cos A, so it will basically be 2 secant A. Hence proved. In the third question, they're asking us to prove tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta is equal to 1 plus secant theta times cosecant theta. So we can represent tan theta and cot theta in the terms of sine theta and cos theta. So tan theta can be represented as sine theta by cos theta whole divided by 1 minus cos theta by sine theta plus cos theta by sine theta whole divided by 1 minus sine theta by cos theta. And on the denominator, we can make sure that they both have the same denominator. So sine theta by cos theta by sine theta minus cos theta whole divided by sine theta plus cos theta by sine theta by cos theta minus sine theta whole divided by cos theta. And sine theta and cos theta will be brought over to the numerator, so we will get sine squared theta by cos theta times sine theta minus cos theta plus cos squared theta by sine theta times cos theta minus sine theta. And in order to further simplify this, we need to ensure that they both have the same denominator so that we can add both of the terms. So we will notice that we here over on the left hand side we have sine theta minus cos theta. Here we have cos theta minus sine theta. If we multiply this by the negative sign, it will become sine theta minus cos theta. So that means we will have one term that is same on both terms. So we can get sine squared theta by cos theta times sine theta minus cos theta minus cos squared theta by sine theta times sine theta minus cos theta. And we're going to bring sine theta over to the numerator on the first term. So we will get sine cubed theta minus cos cubed theta whole divided by cos theta sine theta times sine theta minus cos theta. This is in the form a cubed minus b cubed, and we know that a cubed minus b cubed is equal to a minus b times a squared plus b squared plus AB. And A is sine and B is cos theta. So when we write sine cube theta minus cos cube theta in this form, we will get sine theta minus cos theta times sine squared theta plus cos squared theta plus sine theta cos theta, whole divided by cos theta sine theta times sine theta minus cos theta. And sine theta minus cos theta will get cancelled. So we will be left with sine squared theta plus cos squared theta is equal to 1. So 1 plus sine theta cos theta by cos theta sine theta. And since this cos theta sine theta is common for both the numbers 1 and sine theta cos theta, we can write it as 1 by cos theta sine theta plus sine theta cos theta by 1. So cos theta sine theta will get cancelled, so it will equal to 1. So 1 by cos theta sine theta is basically secant theta times cosecant theta plus 1. And this is what they're asking us to prove. In the fourth question, they're asking us to simplify 1 plus secant A by secant A is equal to sine squared A by 1 minus cos A. So they've given us a hint that we need to simplify both the right hand side and the left hand side. So first, on the left hand side, secant A can be represented as 1 by cos A, whole divided by 1 by cos A. And this can be further written as cos A plus 1 by cos A by 1 by cos A. So cos A will be brought over to the top, so we will get cos A times cos A plus 1 divided by cos A. Cos A and cos A will get cancelled, so we will be left with cos A plus 1. On the right hand side, we have sine squared A and 1 minus cos A. We know that sine squared A is basically 1 minus cos squared A. And 1 minus cos squared A can be written as 1 minus cos A times 1 plus cos A, whole divided by 1 minus cos A. 1 minus cos A and 1 minus cos A will get cancelled, so we will be left with 1 plus cos A. Hence, we can say that LHS is equal to RHS. In the fifth question, they've given cos A minus sine A plus 1 whole divided by cos A plus sine A minus 1 is equal to cosecant A plus cot A. And they've also given to us that we need to use cosecant square A is equal to 1 plus cot square A in order to solve this. So first, since we need to arrive at cosecant A plus cot A, we're going to divide both the numerator and the denominator by sine A. And so it'll be cos A by sine minus sine A plus 1 whole divided by sine A by cos A plus sine A minus 1 whole divided by sine A. So cos A by sine A is equal to cot A minus 1 plus cosecant A whole divided by cot A plus 1 minus cosecant A. So now, since we've arrived at this, at the numerator, we have cot A plus cosecant A minus 1 whole divided by cot A minus cosecant A plus 1. So we know that cot square A plus 1 is equal to cosecant square A. And 1 can be written as cosecant square A minus cot square A. So using this identity, we're going to substitute the value of 1 as cosecant square A minus cot square A. So we will get cot A plus cosecant A minus cosecant square A minus cot square A whole divided by cot A minus cosecant A plus 1. This is in the form a squared minus b squared. So it can be written as a plus b times a minus b. So we will get cot A plus cosecant A minus of cosecant A minus cot A times cosecant A plus cot A, whole divided by cot A minus cosecant A plus 1. So here we can take cot A plus cosecant A commonly outside, and when we do that we will get cot A plus cosecant A times 1 minus cosecant A minus cot A, whole divided by cot A plus 1 minus cosecant A. So when we multiply the negative sign inside the bracket, we will get cot A plus cosecant A times 1 minus cosecant A plus cot A, whole divided by cot A plus 1 minus cosecant A. So we will notice that 1 minus cosecant A plus cot A is equal to cot A minus cosecant A plus 1. So we can cancel both of these terms. So we will be left with cot A plus cosecant A, which is what they're asking us to prove. In the sixth question, we have to prove whole root of 1 plus sine A by 1 minus sine A is equal to secant A plus tan A. So we're going to multiply 1 plus sine A inside the whole root for both the numerator and the denominator. So we will get 1 plus sine A times 1 plus sine A, whole divided by 1 minus sine A times 1 plus sine A. So when we do that, we will get 1 plus sine A the whole squared divided by 1 minus sine square A, because this is in the form a plus b times a minus b. So we know that 1 minus sine square A is equal to cos square A. So we can write 1 plus sine A the whole squared by cos square A. And the square for both the numerator and the denominator is common, so we can take that outside. So we can write 1 plus sine A by cos A the whole squared. So the square and the root will get cancelled, so we will be left with 1 plus sine A by cos A. And since cos A is common for 1 by cos A and sine A by cos A, we can write it as 1 by cos A plus sine A by cos A. And 1 by cos A is equal to secant A, and sine A by cos A is equal to tan A. Hence proved. In the seventh question, they're asking us to prove sine theta minus 2 sine squared theta whole divided by 2 cos squared theta minus cos theta is equal to tan theta. So first, we will notice that sine theta is common for both of the terms, so we can take that commonly outside. So we will get sine theta times 1 minus 2 sine theta. Here we will take cos theta commonly outside, we will be left with 2 cos theta minus 1. We know that cos squared theta plus sine squared theta is equal to 1. And cos squared theta can be represented as 1 minus sine squared theta. So we're going to represent cos here in the terms of 1 minus sine squared theta. So we will get sine theta times 1 minus 2 sine theta by cos theta times 2 times 1 minus sine squared theta minus 1. So when we multiply 2 inside the bracket, we will get 2 minus 2 sine squared theta minus 1. So we will get sine theta times 1 minus 2 sine theta, 2 sine squared theta, whole divided by cos theta times 2 minus 1 is 1, so 1 minus 2 sine squared theta. And 1 minus 2 sine squared theta will get cancelled. We will be left with sine theta minus cos theta, which is equal to tan theta. Hence proved. In the 8th question, they asked us to prove that sine A plus cosecant A the whole squared plus cos A plus secant A the whole squared is equal to 7 plus tan square A plus cot square A. So we know that this is in the form A plus B the whole squared. So it can be written as sine square A plus cosecant square A plus 2 sine A cosecant A plus cos square A plus secant square A plus 2 cos A secant A. And here we have sine square A plus cos square A. And we know that sine square A plus cos square A is equal to 1. So we're going to write that together. Sine square A plus cos square A plus cosecant square A plus secant square A plus 2 times sine A cosecant A plus 2 cos A secant A. Sine square A plus cos square A is equal to 1. And we know that cosecant square A can be written as 1 plus cot square A. And secant square A can be written as 1 plus tan square A. And we have 2 times sine A times cosecant A, which can be written as 1 by sine A. And sine A will get cancelled. So we will be left with 2. Similarly, 2 times cos A times secant A, which is 1 by cos A. Cos A and cos A will get cancelled, so we'll be left with 2. So we have 1 plus 1, which is 2, plus 1, which is 3. 3 plus 2, 5. 5 plus 2, 7. So we have 7 plus cot square A plus tan square A. Hence proved. In the 9th question, they're asking us to prove cosecant A minus sine A times secant A minus cos A is equal to 1 by tan A plus cot A. And they're also telling us to simplify both the right-hand side and the left-hand side separately. So first, taking the left-hand side. Cosecant A is the reciprocal of sine A, so 1 by sine A minus sine A, times secant A, which is the reciprocal of cos A, minus cos A. So we will get 1 minus sine square A by sine A, times 1 minus cos square A by cos A. We know that 1 minus sine square A by sine A times 1 minus cos square A by cos A. We know that 1 minus sine square A is equal to cos square A, and cos square A by sine A, and 1 minus cos square A is equal to sine square A by cos A. So cos A and square will get cancelled, the square and sine A will get cancelled, so we will be left with cos A times sine A. Similarly, on the right-hand side, we have 1 by tan A plus cot A. And tan A and cot A can be written in the form of sine A and cos A. So we will get 1 by 1 by sine A by cos A plus cos A by sine A. So that in order so that both of the terms have the same common denominator, we're going to cross multiply, so we'll get sine square A plus cos square A by cos A sine A. So 1 by sine square A plus cos square A by cos A sine A. Cos A sine A will go to the top of the numerator, so we'll get sine A cos A by sine square A plus cos square A is equal to 1. So we get sine A times cos A, and similarly on the left hand side we got cos A times sine A, so we can say that the LHS is equal to the RHS. In the 10th question, they're asking us to prove 1 plus tan square A by 1 plus cot square A is equal to 1 minus tan A by 1 minus cot A the whole squared, which is also equal to tan square A. So we need to prove that 1 plus tan square A by 1 plus cot square A is equal to tan square A. And we need to prove that 1 minus tan A by 1 minus cot A the whole squared is equal to tan square A. So first, we'll prove 1 plus tan square A by 1 plus cot square A is equal to tan square A. So we can write cot square A in the terms of tan. So we can write 1 plus tan square A, by 1 plus 1 by tan square A. So next, we need to make sure that they both have the common denominator. So we'll get 1 plus tan square A by 1 by tan square A plus 1 by tan square A. So we're going to bring tan square A over to the numerator, so we will get tan square A times 1 plus tan square A whole divided by tan square A plus 1. Tan square A plus 1 will get cancelled, so we will be left with tan square A. Similarly, we need to prove that 1 minus tan square A by 1 minus cot A the whole squared is equal to tan square A. So similarly, like the first part, we're going to represent cot A in the terms of tan. So we'll get 1 minus tan A by 1 minus 1 by tan A, the whole squared, which we will get 1 minus tan A by tan A minus 1 by tan A, the whole squared. And when we bring tan A to the numerator, we will get tan A times 1 minus tan A, the whole by tan A minus 1, the whole squared. So we will get tan A minus tan square A by minus of 1 minus tan A, the whole squared. So when we simplify this, we will get minus tan A the whole squared. And we know that minus tan A the whole squared is also the same as tan square A, hence proved.